Newton's laws of motion supply the mathematics underpinning all of the motion you are likely to come across in your day-to-day lives. Newton's laws give us a mathematical definition of force, measurable through observable data. Newton's laws are, in short, the fundamental principles behind every form of motion at a relatively low speed. Although Newton is hailed as the father of mechanics, he didn't work out all the principles of motion by himself. He carried on the work of Galileo, but now he removed a fundamental problem of motion on Earth, that of friction. Simply stated, Newton summarized all forms of motion into just 3 rules. These 3 rules can be studied individually, but affect all bodies equally. The first law isolates friction as another type of force. All bodies will continue in the same state of motion unless acted upon by an external force. The second law quantifies force, tells us how to deal with more than one force, and gives us a method of measuring force. The sum of the forces acting on a body are equal to the rate of change of momentum experienced by that body. The third, and most often quoted law, tells us about the nature of forces in general and how they work in the real world. It explains friction and why motion is generally more limited than the first 2 laws imply. For every action, there is an equal but opposite reaction. We will go on to discuss each of these laws in detail through examples.